All right, I'm going to go ahead and get started. Because as usual, we've lost 10 minutes of the meeting to technical difficulties, but we'll just see how it goes. All right, so the purpose of this meeting, a few of us have been working on Agilis's first React application, which is the customer back office. And this is sort of a high-level tech overview of the stack that we're using. And a little bit of a dive into how these different pieces work, how the React library and the Redux data container library work together. So let's start with React. So it's a JavaScript library from Facebook. It was released in 2013. It's been dog-fooded by Facebook. They use it on all of their main properties.
Philippe, I'm actually listening to
Ed,
you and...
please?
Pardon?
Can you mute, please?
I'm so sorry. I'm trying to get Philippe, and I thought I was muted. I'm so sorry.
No worries. So it's mature at this point. It's been, like I said, out since 2013. It popularizes some key ideas, none of which are new, with the exception perhaps of the virtual DOM. But the two big ideas that it popularizes are component-based UI and one-way reactive data flow. And the basics, in a really simple, highly abstracted nutshell, is a UI component takes arguments, which are properties called props, and they then implement a pure function which outputs the result of the rendering of that component. So it should be immutable, should be deterministic. And then whenever those props change, the component re-renders. There are also stateful components, which we'll talk about in a second, but it's the same thing. The component maintains its own state, and whenever that state changes, it re-renders. So the component-based UI architecture is just the idea of encapsulating behavior and appearance in a self-contained component. So in React, you build a UI out of a component tree, and then React, when it compiles, turns that into a DOM tree. So the simplest form, and this is actually reasonably new to React, is just a pure function that returns the render, essentially. And so here it's actually using the API exposed by the React object, which is create element. So it's going to create an H1, and it's going to put the following content inside it. However, React exposes their own language called JSX, which is a superset of JavaScript that allows you to embed XML, XHTML style markup directly into your render function. It saves a lot of boilerplate. Takes a little getting used to at first. A lot of people have flashbacks to PHP and classic ASP and Cold Fusion, but it is actually a different concept. And as you use it, it makes a lot of sense, as these are self-contained UI components with the behavior and style and markup all encapsulated. It makes sense to have your markup along with your logic. And then I mentioned stateful components. Anytime a component needs to maintain its own state, and this is usually useful for things, what they call controlled components. So for example, maintaining the sort direction of a grid, or maintaining data bound to form inputs, things like that. And in which case you extend the component object exposed by React, and you can set state, and then whenever that state changes, the component re-renders. Also, if you extend the React component object, you can hook into lifecycle methods of the component. And there's some interesting things you can do with that, but they're kind of beyond the scope of this talk. So the other important concept that React exposes is virtual DOM. There's a lot of hype about virtual DOM, but it is definitely the least important of the major concepts, in my opinion. But it is still important. And the idea is that, you know, as web developers, we've been taught, and it's been ingrained into our brains over the years, that reflow and repaint of the DOM is expensive, and it is. Now, modern browsers make that less of an issue than it used to be, but it's still the single most important thing you'll do in a web browser is a reflow and a repaint. So we've always been taught to minimize the number of actions that can cause a reflow and repaint. And so what this virtual DOM essentially is a reconciliation algorithm. It's a diffing algorithm. So it maintains a representation of your DOM in memory. And then when that render function is about to be triggered, it figures out the differences between the previous in-memory representation of the DOM and the actual DOM, and then it only renders what's changed. So basically, it frees devs from being concerned about optimizing reflows and repaints. Again, it's important, but it's not nearly as important as the other things. And arguably the most important concept that's popularized by React as far as front-end development on the web is one-way reactive data flow. So this is essentially reactive programming. So I mentioned that a React component takes in properties as arguments and then should deterministically render based on those properties. So data only flows from the top of a tree or subtree downward, and then events flow back upwards. So events are callback functions essentially. And since JavaScript supports first-class functions, those functions can be passed as arguments along with the data as props, and they can be invoked at a leaf node, but the event handler actually lives somewhere further up the tree and it's co-located with the data that it mutates. So data only flows downwards. Props are read-only, they can't be mutated. The event handlers are passed down, event handlers are co-located with the state they modify. And this combination of things makes applications, UI applications, easier to reason about because you can always tell where the state was modified, how, and you know that the data is only flowing downwards. So why did we choose React? It is, as the framework war is starting to slow down, this framework churn in JavaScript starting to slow down, the two clear winners at the top are React and Angular. Vue is a close third, Ember is a distant fourth. But realistically, it's between Angular and React at this point in the game. It's mature, it's been battle proven by Facebook. And this concept of pure functions, for those not familiar with functional programming, a pure function is a function that, when given the same arguments, always returns the same results and also has no side effects. So it never mutates anything outside of its own scope. And this idea of each component having a pure render function that becomes the input, its output becomes the input to another render function higher up the component tree, essentially gives you a paradigm of a monad of pure rendering functions. Now, because your render functions are pure, that is, when you pass a component the same props, the render should always be the same. It's deterministic. It makes it easier to reason about application state. And then because this is first of all, a library versus a framework, it has a smaller surface area. And that surface area is limited to constructs specific to React. And then everything else is JavaScript. So many of us are familiar with Angular that has these proprietary constructs, these directives, ngIf, ngShow, ngHide, ngRepeat. In React, all those things are done with plain JavaScript. You use if statements. You use array.map or array.forEach or array.reduce. And then there's also a compelling story behind React Native. So React Native is a sister project to React, and it allows you to use most of the same code. And then React decouples the rendering from the internals such that for a website, you use React DOM. For a mobile application, you use React Native, and then it also exposes components that you can use, which correspond to actual native components on the platform of your choice. So when you write a React Native application, you actually produce a native application for Android or a native application for iOS. So there's something compelling there. You can reuse a good chunk of your JavaScript code, but you end up with a performant, fully functional native application. So now on to Redux. Redux is a predictable state container written by a guy named Dan Abramov, who's since been hired by Facebook. And it's an implementation of Facebook's Flux architecture. That's their reference architecture for React apps. There's a couple of differences. Flux has multiple data stores. Redux has a single data store. That store contains state that's read-only. The state is never directly mutated. The only way you can change the application state is by pure reducer functions that produce new state idempotently. And so in a nutshell, how it works, an application dispatches an action, and that's just a plain object that describes what's happened. That action goes through one or more pure reducer functions, which based on the action will produce new state. And then the application can subscribe to those changes in the state and then react accordingly. So I mentioned a single source of truth. This is actually a screenshot from the React DevTools, which we'll look at in a minute. And this is the initial state of the customer back office application. And it's just an object tree. So at the root is that state object. And then we deal with slices of that, or subtrees, for portions of the application. So immutable state pure reducer functions, this is a snapshot, or a snippet, if you will, of one of the reducers from the application. And the pure reducer function takes the form of two arguments, state and action. And then it's just a switch statement, the default of which, if the action is not recognized, is just to pass through and return the state unaltered. If there is an action that matches, we use here object.assign, and we produce a new object by mixing in the existing state and then any changes that we want. So these reducer functions always produce new state. You never mutate the existing state. So there's no chance of side effects from mutating state. So there are two types of actions that can be dispatched. There's synchronous actions, which happen in real time. You have an action, it goes through the reducers, and you produce new state. And this is not an entirely accurate diagram, but it's the best one I could find out there. The only thing that's kind of inaccurate is there is no dispatcher in Redux. That's a concept from Flux. That really should be labeled dispatch function, but it still gives you a basic idea. So somewhere the user initiates this action, which is either a deposit or a withdrawal. It goes through a dispatch function. That action is dispatched. And then the reducer figures out what to do with it, produces new state that gets passed back to the UI. But this all happens sequentially. The other type of action that can happen is an asynchronous action. And so this is, by necessity, certain actions, certain things that happen in an application have to have side effects. For example, an XML HTTP request. It's going to go outside of your process and allow the host environment to initiate some action. And then it's going to potentially mutate the state of your application with new data that comes back. There's a variety of different asynchronous actions that can happen, but the point being is that side effects can be contained inside an asynchronous action, and then the result gets passed through to the reducer. And it looks something like this. This is accomplished with middlewares. And these middlewares are pieces of software that sit in between the action being dispatched and the reducer being invoked. And so in this case, the middleware, it can potentially trigger a sequential action that says, like, I'm starting to do this thing, turn a spinner on or something like that. It'll dispatch an asynchronous request, and then when that comes back, the middleware handles dispatching the result. So why do we choose Redux? Well, it's an incredibly simple little library. It's elegant, it's a powerful construct. It shares a lot in common with event sourcing, for those who are familiar with event sourcing. It's also roughly comparable to a client-side database. And it turns out to be just a really robust and powerful way to do state management. It's predictable, it's deterministic. The idea behind Redux is that dispatching the same sequence of actions with the same payloads should always result in the same application state. And in fact, hooking into that dispatch, the Redux dev tools and other tools out there allow you to do things like time traveling, where you can go back in time and replay a series of actions, and your state should always be the same. It's tiny. The core library is just 254 lines of code. The surface area of the API consists of exactly 3 methods: dispatch, subscribe, and get state. And then when we combine that with React and its deterministic view rendering, we essentially get this completely decoupled, event-based, deterministic platform that makes building these applications simple and easy to reason about. So let's look at how these two things work together. So basically, the core ideas here are you have a component that takes props in React still. So what you do is you pass props that are leaf nodes or subtrees of the Redux state. You pass those to components. Whenever the Redux store changes and those relevant nodes or subtrees change, so do the props that get passed to the components, and the components essentially re-render in response to those changes. And then when you want to dispatch actions off to the Redux store, since we can pass actions or dispatch functions as first-class citizens and arguments to the components, we can then pass in those dispatch functions and they can be invoked from the components in response to a user interaction. I have an asterisk there on user interaction because there are other places you may want to dispatch functions, such as component lifecycle hooks, which I mentioned before. We'll touch on those as we look through the code. But the components are logic-free at that point. We do all of our querying of the store, all of our reading of the store, and all of our dispatching externally. And we just allow the components to take in props, take in functions, and invoke them. And so it looks something like this. So we have this Redux store, and we have an object tree, and we want to take certain pieces of that and pass them over to our component. And then when the component does something in response to either a lifecycle hook or a user interaction, we want to dispatch an action that mutates or changes the store. So we could do this ourselves. You know, it's, as I said, the API for Redux is tiny, but it does involve a little bit of boilerplate that we'd rather not have to repeat in all our components. And so the guy that wrote Redux wrote React Redux, which is the bindings for React. And so essentially what it achieves all of those things by wrapping your component in a higher order component. So a higher order component is just like a higher order function. It's a function that returns a function. So there's a function called connect. You pass it your component along with a couple of functions that return a hash mapping which pieces of the store or state you want to map to properties of your component, and which dispatch functions you want to map to properties of your component. And it creates a new component, a container component, that wraps your existing component with all the plumbing needed to dispatch those actions and subscribe to property changes. And it tastes great together. So let's look at some code. So this is the customer back office application. And please chime in at any time with questions. All right, so let's look at React first. So this is a logout component. And the important piece we're going to look at right now is just from here, right here, to right here. So this is a stateless functional component. We know this because our React component is just a function that has no state property. And at the top here, you'll see this little prop types. The prop types is another library that's bundled with the React View library. And basically, it provides at development time type checking, which is a novelty, not really that important. More important, it provides a contract to your component. So reading prop types, you know what should be expected to be passed in. You can also specify default props here. And so this logout component is incredibly simple. We're going to pass it in a flag for whether or not we're authenticated, a flag for whether or not auth data is loading, and we're going to pass it in a function to handle a logout click. And so in our render, we're basically just going to, if we're authenticated, return some markup or just return nothing. If your component shouldn't render, you just return null. And in this case, if we're authenticated, if we're loading, we're going to render a spinner. If not, we're just going to render a button that says logout. And then we have a local function, an event handler for the click event. And in that event handler, we're going to call the function that was passed in as a prop. Any questions on that? Should be pretty straightforward.
Yes, I have a question.
Yes.
Why you have a CSS style there?
I'm sorry, can you repeat that, Marcia?
I'm sorry, yes. Why you have CSS styles in
Why do I have CSS styles? That's an excellent question. So that main button component here, this is a wrapper that we wrote around a component from a library called Material UI. And Material UI is a React implementation of Google's Material Design. And that component accepts a style object that allows you to override inline styles. So it's part of a broader discussion of how to style React components, because React components are completely self-contained. There is a strong sentiment that they should use their own internal styles. And so because you can pass JavaScript objects into it that define all the styles, you could potentially achieve the same thing you would with cascading style sheets just by having a top-level object of styles and passing that into components. As a real quick side note, the folks that maintain Material UI are going to change course. They originally built the whole thing with inline styles, but they found from a performance standpoint that it's not as fast as it would be with external styles. So that is going to change. But the purpose of this is we're passing those through to a button component exposed by Material UI to style that button with inline styles.
Okay, thank you.
Sure. Any other questions on that before I move ahead? Okay, so let's look at testing a simple component. So a couple of interesting things. For testing, because these are UI components, we need to render them. And so there are a couple of different rendering libraries out there. By far the most popular and widely adopted is one from Airbnb called Enzyme. So that's what we're using. And then we have a couple of utilities here that are specifically needed for that Material UI library. But basically, these are just wrapping the shallow and mount functions from Enzyme. And what these do is they mount like an in-memory DOM, essentially. The shallow render only goes one level deep. The mount render completely mounts the whole component in its entire subtree so that you can test it. And so one of the first and simplest tests that we can do on a component is what's called a snapshot test. And what this does is it just outputs the result of the render to a JSON object such that we can do visual regression testing. So that anytime our markup changes, the snapshot test will fail and we have to update it. We basically get this little snapshot, right? It's a super simple test, but it gives us a clean visual regression. And then, we talked about idempotent or deterministic rendering of views. So the basic gist behind testing a simple component is to render it out with a set of props, well-known props, and verify that the pieces that you expect to be rendered are rendered. And so that's what we have here. So if we're authenticated and we're not loading, we should expect to see that main logout button. If we are authenticated but still loading, we should expect to see a modal container. So this is a real simple case. Just to illustrate basic testing, we're going to look a little bit more at testing in a moment. Any other questions on that, though? Okay, so that's React 101. That's basic React. So now let's talk about Redux for a moment. So I mentioned that Redux consists of dispatching actions, processing through a pure reducer function, and subscribing to changes that result from that the new state produced by the reducer function. So actions are just plain objects. Now, it's a pretty well accepted practice to have a function return those objects just to keep your code dry and reduce typos. So here what we see is a bunch of simple synchronous action creators. So they're little functions that we can invoke that will return an action object. So the simplest one here just has a type, do login. By itself, it doesn't really mean anything until we pass it through a reducer. And then here we have a slightly more complex one that takes some data, some sort of a payload, and the action object that it returns has the type of action and the payload that goes with it. So they don't mean anything by themselves until we pass them through reducers. So here's a reducer function. So we're going to import a bunch of our constants that recognize or keep our actions typo-free. And then we're going to use ECMAScript 2015 default arguments to provide an initial state. So this is when you first boot up your Redux store, when this reducer is first invoked, if the state that it's monitoring is empty, you can give it an initial state. You could also do this when you first bootstrap your Redux store. You can provide it an initial state, and that's useful if you're doing server-side rendering, which we are not. But basically, our reducer function here is just a big switch statement. It says, check the action type, and if that action type is handled in here, do something with it. And if not, the default is always just to pass through the existing state. So no changes take place. But you can see these are pretty simple. So when we say that a login, we're about to do a login, we get that action dispatched. And all we're going to do is take the existing state, add set is loading to true, and return a new object with all those properties mixed in. If, on the other hand, we've just successfully logged in, we're then going to merge in the results of that login call and set loading to false, authenticate it to true, and make sure that we've cleared out any errors that we may have had on a previous login attempt. And the rest of these all pretty much follow suit. But the basic idea here is that anytime an action matches, we're going to produce new state either based on the existing state or based on our initial state. Now, we never directly mutate state. So we've seen actions. And these actions get the basic way to do a dispatch of an action is to call store.dispatch and the action. We've seen a reducer, which is what those actions get passed through. So now let's look at a subscriber, store.subscribe. This is a really simple illustration of a subscriber without any of the Redux React bindings. So what we're going to do is we're going to get a handle on store.subscribe, and this callback gets called anytime the store changes, anytime that state changes, any portion of the state. We don't get to determine what point we're watching. What we do instead is when it changes, we then select a portion that we're interested in looking at. So we'll look at auth selector in just a moment, but suffice it to say, this is a function that selects some portion, some subtree out of the root level state that's in the Redux store. And basically, we just want to see if it's changed. If it's changed, we're going to do something. And if, depending on what the state of authentication is, in this case, we're clearing or starting out a new session. And that basically just involves putting an X token into a cookie. All right, so I talked about selectors. That's the next important thing. So selectors are just functions that pluck out some portion, some subtree of the main state tree that you're interested in. And the best way to think of selectors is they're your API for reading your store. The generally accepted best practice for your Redux store is to keep it as flat as possible, flat and denormalized, just like a database. And then use selectors to create computed values at runtime. Now, that can be expensive if you have a lot of computations. And so what we're using in these couple of selectors that I'm going to show you, we're using a library called reselect. But before we look at reselect, at the very top here is just the simplest version of a selector function. Basically, we're going to create a function that takes the state tree and returns some portion of it. Super simple. From there, the rest of the selectors in here are going to use this reselect library. And what reselect does, or this create selector function, is it creates a memoized function based on the results of another selector. If you're not familiar with memoization, it's a technique for caching computed results such that when the inputs to a function do not change, you return the cached results. So it should give you a performance benefit. The performance, of course, is at the sacrifice of storage because you have to store those cached results. But unless you're dealing with a large volume of data, the performance benefits outweigh the storage. And so that's important. The memoization is important from a computational perspective. And if we look at another group of selectors here, that story becomes a little bit more evident. Here we're taking a flat array of business context objects, and then we're creating hierarchy trees out of them, and then figuring out where the parents are, and then reflattening them. And so there's a fair amount of computation that happens here. So the performance savings are important, but what's more important, I think, by creating these layered selectors that take the input of one to produce the next output, is they create a story. They show you step by step how this data is being transformed. And they're pure functions. They should always have the same outputs from the same inputs. And it makes it easy to see step by step how you get to the last result, which is this flattened array of just context IDs and names for leaf nodes. So that's selectors. Any questions on selectors? I'm going to move fairly quickly here because we're getting close to being out of time. Okay, so that's how Redux works in a nutshell. You have actions, they get dispatched, they get processed by pure reducers, and then you subscribe to changes and you read the state tree using selectors. So now let's look at how those two things work together. So this is a login component. It's a little bit more complicated than the logout component. First of all, it's a stateful component, and it's stateful primarily because it needs to maintain the username and password data that's bound to form fields. And it takes in the following properties that we saw. A couple of these we saw in our logout: is authenticated, is loading, potentially a last auth error, which can either be a string or an object. And then it takes in a function, which is an event handler for a login click. Location is something coming from React Router, which we're not going to touch on. But essentially, we're rendering out, if we look down here, we're rendering out a login form. Okay? And we have some bound properties. So this is the internal state of the component, the username and password. It's not that, I'm not going to go into the details of how this works, but it's basically just a login form. But what's interesting is that we want to get these pieces of information, particularly as authenticated is loading and do login. We want to get these from the Redux store, and or we want to be able to dispatch actions to the Redux store from this component. And the way we do that is by using the React Redux bindings. And so I mentioned earlier in the slideshow a function called connect, which is a function that returns a higher order component. And so it's a function that takes a couple of functions as arguments, and those functions return maps of properties from the state tree in the store and dispatch functions that should dispatch actions back to the store. And then it returns a function that takes your component and returns a new component with all this plumbing built in. So in a nutshell, what this is doing, it's going to wrap your component and automatically pass it these three properties: is authenticated, is loading, last auth error. And those properties are going to correspond to the properties in the state tree, such that whenever that state tree changes, this higher order component, this wrapper around your component, will automatically pass those properties to your component. And the dispatch to props is going to automatically pass your component a function called doLogin. And that doLogin is going to, in turn, dispatch an action to the Redux store, which brings us to asynchronous actions. So in this case, login is a side effect action. It's going to actually cause things to happen outside of itself. It's going to cause the browser to initiate an XML HTTP request. It's going to traverse network boundaries, it's going to bring data back, and it's going to hook back into our event loop. So the way we are choosing to handle that is using a middleware called Thunk, Redux Thunk. And if we go back to our authentication actions file, what a thunk is a function that's invoked at runtime as an intermediary between two operations. And so in the case of Redux Thunk, this intermediary function is invoked in between the time you call dispatch and the time the reducer gets the results of the actions. And so in a nutshell, this login function returns the thunk, the function, which is provided dispatch, and dispatch is store.dispatch from the Redux store. Inside of that, you can dispatch synchronous actions. So in this case, this is just one that says we're logging in, start a spinner. And then we're actually going to do our asynchronous action. And when it returns, we're going to do another synchronous dispatch. And so these two pieces are handled for you by the Thunk middleware. And it allows us then to keep any of this side effect asynchronous operations outside of our controllers. It lets our controllers be entirely predictable. We get some props, we do something. The props change, we re-render. We don't worry about whether or not there was a network error. We don't worry about how long it takes for this thing to resolve. We keep all of this side effect behavior encapsulated within this Thunk, which is kind of the beauty of Thunks.
Could you please spell the word you're using?
I'm sorry?
Could you please spell the word you're using? Thunk?
Thunk, like the past tense of think. Thunk.
Thank you.
And that's exactly what it's intended to be, a past tense of think. Okay, so we've seen what a container looks like. And in this case, we're using the magic of ES6 modules to do a named export of our dumb presentation container so that we can test that. And then our default export that gets used by the application is this connect container component. This is the one that's going to plumb into Redux and actually do something with our application. But we also need to be able to test those containers. So in order to test those containers, what we're really looking at is testing the correct mapping of Redux state to properties and testing the correct mapping of dispatch functions to properties. So in order to do that, we're basically just setting up a dummy store that has just a pass-through reducer and a mock function for dispatch, because we don't really care to actually dispatch actions. We just want to know whether or not the right action was dispatched. And then we're going to use enzyme shallow render, passing in this store object that we created. And we basically just want to make sure that once we render this thing, the props that we are expecting to come from the store actually exist on the component. And then for dispatch, here we actually need to mount this, because our dispatch, in order for us to test dispatch, we actually need to mount out the entire component, particularly if it has component lifecycle methods. But if we do a shallow, all we get is the top level render, which means any nested things like buttons that are rendered as leaf nodes of our login component won't get rendered. So typically to match dispatch, to test matching dispatch, you've got to actually mount the component. And so in this case, we're going to find that dialog that gets rendered, and we're going to find one of its action buttons, which is the login button, and we're going to click it. And when we do that, because our login button's click event, if we go here and find our login button, which is, where is our login button? Oh, this guy's wrapped in a modal container. Our login button is this guy, this main button, and it has an event handler, which is on submit, and that event handler is going to invoke this do login property that we provided to it from the container, which in turn is a dispatch function to the store. So when we click that, we should expect dispatch to have been called. So dispatch here is a mock function, so it's kind of almost like a spy. But we can test whether or not it's been called, and then we expect the argument that it received to be this async login. Does that make sense? John's gone through this about a half dozen times and is still wrapping his head around it. So it's a bit of a paradigm shift, but once it clicks, you have this amazing aha moment. But if there are no questions, let's look at this in action. So this is the customer back office application. And on the right-hand side here, actually, before we look at Redux DevTools, let's look at, and where did our toolbar go here? 1 second. Let's see if we can get it back. There we go. No, we've lost it. There we go. Okay, before we look at the Redux DevTools, let's look at the React DevTools. So when we talk about a React component or a React component tree, we have all these custom elements. So if we go back, let's go back and look at our code again real quick. When we look at the render of one of these components, we have this tree that may have DOM elements like a div in it, but more often than not, we're going to have these custom components. And they don't actually get rendered out to the screen as opaque modal or circular progress. These guys get transformed. The render method of these produces DOM elements. And so our rendered HTML is not really going to resemble much the markup that we have in our code, in our React components. And so in order to assist us with that, there's React DevTools. React DevTools basically shows you, it's a mapping between the rendered HTML and what your components are. So as you can imagine, this is pretty helpful. It also shows you what props are. For those who have ever used Augury or the Angular DevTools, it's very similar. It's a really helpful debugging tool. But the one that's really cool is the Redux DevTools. So the Redux DevTools gives you a visualization of your state tree. And let me get rid of this console here. You can also there's an inspector that lets you see the sequence of events here. You can look at what the tree is, the result of the tree. You can look at what the action was that was dispatched, the state, the difference between the current and previous action. And the other thing, and it doesn't make a whole lot of sense here because this action was dispatched by the React router for Redux. But when we get into our code, this will make a lot more sense. But let's go back to our state tree. So when the application starts up, this is the state tree. There's not a whole lot there. There are some subtrees fleshed out, but they're all empty. There's nothing in these guys, right? This basically corresponds to the initial state that we gave the reducer. Just basically has nothing in it, right? But when we do something, all of a sudden this will start getting interesting. So let's go ahead and say we're going to log in. So when we log in, we're doing a couple of things. We're going to dispatch an action that says do login, which is going to set this is loading flag to true. And then that thunk middleware is going to actually, on our behalf, make an async request to log in. And when it returns, it's going to populate the remaining information here. And then we're also going to, once we're authenticated, we're going to make a user details request to go and get the password expiration, other things about the user. And we should see this tree expand for us. So all of a sudden, the tree expanded. We now get this really nice visualization of our tree. Right? So we've now, in the background, also gone and fetched all the business context we need to populate our context picker. We have a whole bunch of stuff that's been populated for our user over here. And so now if we select the context, we are going to now have a whole bunch of other information that gets populated. In fact, our user details request gets populated by this component, which is our user display component. But the point of this is that you can visualize the state of your application at any time. Right? And that's really cool. But what's really neat is this Redux DevTools takes advantage of the fact that you can hook into that dispatch, grab a snapshot of the state the way it was prior to a dispatch, and then cache all the actions that have been dispatched along with that state, and then you can travel back in time and go back to a state prior to where you were. And then if you replay that, you should get the exact same state tree as a result. Right? So this is all action-driven and should be entirely predictable. Right? There should be no difference here between the result of this state tree and what we did previously. So now that we have some actions actually in our log, now we can look at all of these things that happened here, right? So if we go to like context received, for example, we can look at, this is what the state tree that we're monitoring with this particular reducer looks like. And we can see it in raw form if we want. Here's the JSON. Here's the action that caused it. This is what the state tree, the entire state tree looks like. But what's really cool is it also gives you a skeleton unit test for testing your reducer. Now, obviously, this has the hard-coded data in it, but this could still be a tremendous time saver for writing automated unit tests. So all super, super cool stuff. Let's see. Any questions on that? We got about 9 minutes left. So
Yes, I have a couple of questions.
Yeah, go for it.
Can you go to the code, please? This is just curiosity. I can see two test files or kind of test files. For instance, you have a login.test.js, but also you have a logout.spec.js. What is the difference to have test and spec?
I'm sorry, you're asking what's the difference between login and logout?
No, the extension of the name of the files. In my perception for login.test.js file is like a unit test, but also my perception for logout.spec.js is unit test too. Why the difference of the names?
I'm not sure I'm following you, Rosie.
I'm sorry.
No, that's okay.
Can you go to logout.spec.js file, please?
The logout file?
Spec. The test.
The test. This one.
Yes, that is a test. Okay. But if you go to login.test.js file.
Yes, so that's actually, I just noticed that right before I was putting this together. It turns out, so all the documentation that I read when I was getting started, the testing tool we're using here is Jest, which also was written by Facebook, and it's their preferred tool for testing React. And the other thing I'll cover real quick before we close is how we scaffolded this application. All the documents, all the examples show the file names ending with .test.js, but on closer inspection, the default configuration also respects .spec.js. And so in a recent PR, I went through and changed all of them except that one, it looks like.
Okay, so basically it's unit test.
But it's totally immaterial to how the test works. It's just a file naming pattern that the test runner looks for.
Okay. Okay, I was thinking that it was a different kind of test. That's why
it's not, but good call, good call. So, but that does bring to the forefront. So, so in order to get permission from the architecture committee to use React, there were certain hurdles that had to be surmounted. one of which was how do we standardize the scaffolding and tooling that we use for these applications. And so for a while, the community was doing this via various seed and boilerplate projects, but Facebook finally got behind a project called Create React App, which is a command line tool for scaffolding and running React applications. So when you use Create React App, it sets up a complete functioning skeleton of a project for you, including a development server, a Webpack configuration, Jest configuration, ESLint, and a whole bunch of other things ready to go out of the box. And as part of that, it includes this test tool called Jest. Jest is nice for a couple of reasons. The first is it's somewhat convention-based. In other words, it by default just looks for all the files in your thing called .test or .spec.js without you having to tell it. It's super fast and it runs in parallel. So it'll spawn off different processes in parallel to run your tests as fast as it can. So it takes a moment to scaffold to start up, but when you have it in watch mode, it runs tests ridiculously quickly.
Great.
And it's built on top of Jasmine, so the syntax should look really familiar. Describes and it and etc. Are all the same.
And are you planning to include another kind of test, like acceptance test or end-to-end tests?
We do have end-to-end tests. We'll take a quick look at a couple of those. And the end-to-end tests, I know John recently gave a talk on WebDriver IO, and so that's what we're using here as well.
Okay.
And so there are some E2A tests here, and they're very similar to the ones that we have in existing kiosk and back office UI. There are a few different constructs that WebDriver IO exposes, and I'll leave it to you to ask John for those specifics. But yes, we do have E2E tests. At least we've started some E2E tests.
Yeah, I remember that. Thank you. And the last question about the router. Are you using React router or no? Because you mentioned something about
So yeah, we'll talk about routing real quick. A couple things. So we decided to use Create React App, and then on top of that, we wanted to try and standardize the structure of the application. So we are using React Router, and I'll talk about that just real briefly in a second. But if we look at the structure of our application here, what we ended up doing was borrowing mostly React Convention, which is a community effort to standardize the structure of React applications. And so we've taken probably 90% of that. And so this structure is very similar to what they expose. The only differences are we have test files co-located with the components they're testing, because we have found that having a separate directory structure that mimics the main one and having to scroll between those when you're testing components is cumbersome. So that's one key difference. Another key difference is that we have co-located our presentation and container components. So in their example, they have this login presentational component, this guy here, in a file, and then they have this container component in its own file. And again, the container component is what's typically used by the application. These presentation components are never used by themselves. They're really only used for testing. And also the contents of the container is typically just going to be like, 10 or 12 lines, and which are directly related to the component that they're wrapping. So, I found a couple of different posts from people suggesting this approach, which is to co-locate them. That's the other main difference. But the basic gist of the React Conventions directory structure is you have a components directory, and this contains reusable, sort of generic components that can be used app-wide. And so they're all located in these directories. And then everything else, and then the store is the Redux store. Everything else is contained, trying as best as possible to mimic the routes of the application. So we have a root index route. And so this is using React Router, and Connected Router is a wrapper on top of React Router that hooks into Redux so that we can actually monitor the application's browsing history in the Redux store and time travel with that as well. But just think of it as React Router. And React Router is a declarative router. It's very different from Angular's router, which is programmatic. And so each route is actually a component that has a render method. You can either pass it a component to render, or you can give it a render method. So we have this root path, and it has then the top level routes that it can render out. So we have this root here. We have a login route, and then we have an authenticated context. This context route here is essentially just a matcher. It doesn't actually render anything out. This is to display the context picker, which is a standalone component. But basically what we have at the top level is we have three top-level routes: authenticated context, login, and root. And then all of the application context happens here. So this root is when you have actually authenticated and chosen a context. And so it also has nested routes. So this guy displays our main app layout. And then it has within it a couple of routes that can match, which are going to be home and menus. So this is the pattern that's set out by React convention, is to have you have nested routes, etc. And then if this route, authenticated context, has its own subcomponents, which it does, it has a header component and a navigation menu component. They're in a components folder here. And then any reducers, action selectors go in a modules folder. So this folder structure will repeat itself throughout the application. And so if we look at the application in the browser, let's go ahead and log out. So if we log out, and actually let's go all the way back here. So when this renders, this is the root route. So if you come in here at just the root, you get this interstitial page. Then, depending on where you go, this is one of the top-level routes, login, as is context. And then from there, the only other place you can go is after you've authenticated and chosen the context, you go to this authenticated context route. And then everything else goes as a subroute of here. So we have the home and the menu route.
I see. Okay. Can I make the last question? I promise. It's the last.
Yeah, sure. And people can feel free to stay on as long as they want. I've got a hard stop at 2:30 though.
Okay, thank you. Considering the experience that you already have, what is the most difficult thing that you have to do in React in comparison with Angular?
The most difficult thing in React compared to Angular?
Mm-hmm.
So, I mean, I think we have to take the two together in this case, React and Redux, because Redux is the architecture of our application. I think that in general, once you get over the conceptual paradigm of the bindings between React and Redux, development is much easier than with Angular. There are far fewer proprietary concepts to deal with. You're basically writing JavaScript once you get over a small surface area of React. And yeah, I mean, my experience has been far more pleasant using React and Redux than my experience developing with Angular.
Okay. Oh, I have another question. And this subject is very interesting to me. How long do you think it will take the learning curve in React, approximately?
So honestly, I think learning React, is pretty easy. There's not much to it. Like React has just a few core concepts, and learning React is pretty easy. I think learning Redux is also, by itself, Redux is pretty simple. The biggest paradigm shift is learning how the two work together, the bindings between the two. But seriously, it's like once you have that aha moment, which I had just a couple of hours in, and you understand the basics how it works. You're basically just taking properties, sub-trees or leaf nodes out of that object tree and mapping them to props in your components, and then passing in functions that dispatch actions back to the store. It's just a pattern that repeats itself over and over again. And it becomes clear pretty early on how robust that is. So these things enforce dumb components, right? They help to enforce keeping logic out of your view code. And they make the application state and changes to the application state entirely predictable. And that's one of the biggest problems we've had with Angular. And it's one of the common complaints about Angular. And part of it has to do with two-way data binding. But also, you have services that are maintaining state all over your code. And it's really easy to put business logic inside of your controllers and mutate state there as well. And you end up with state being mutated all over the application. It makes it really difficult to track down exactly what happened, why, and where. And with this architecture pattern and these idempotent views that just render based on data they're passed and never change that data, it helps to enforce the separation of concerns. It helps to keep it really easy to reason about how your application got in a given state. And you can also, one other thing I want to show you real quick here in the dev tools, in addition to the Thunk middleware, we're also using another middleware called Redux Logger. And it does a very similar thing to what the Redux DevTools does. It hooks into those actions that are dispatched and grabs a snapshot of the state, and then it shows you let's find a good one, like login succeeded, okay? It shows you what the previous state was prior to you dispatching this action, and this is basically just gonna be our default state. It tells you what action was dispatched, right? And then it tells us what the resulting state was. So here we've got this audit trail in our dev tools. It shows us exactly what happened. It shows us at any state, at any point along the path, how did our state change? What did it look like before? What did it look like afterwards? And exactly what action dispatched that. So these things all combined are extremely powerful.
Okay.
Any other questions?
No, that's all. Thank you.
You bet. Anybody else have questions? Okay, we're all React and Redux experts.
Before you think that,
Yes, Ed?
I'm just curious. So when will something like this be finding its way into, say, the kiosk UI code?
So that is going to be, at least to a certain extent, up to you guys. So, so part of my pitch to the architecture committee was that, the reason we're choosing this for customer back office is because it's a brand new application, and we don't want to build any new applications on an aging code base from Google, which is Angular 1, which is not going to be supported in the future.
Mm-hmm.
And based on the proof of concept work that I did in research and a bunch of information gained at NGConf back in April, we also were not thrilled about moving to the new versions of Angular because it perpetuates a lot of the same problems that Angular has. And so, React was a natural choice for a new application. Now, when it comes to existing applications, it's a totally different story, right? We have large code bases that are functioning in production. So unless there's a really good pressing reason to refactor those, they're probably going to stay as is for a while. However, once it's determined that a migration needs to take place, there's a couple of different strategies, right? The first is you can do vertical refactoring, where you just take a screen at a time or a route at a time and completely refactor it. And then the other is you can do horizontal migration, which is you start at leaf nodes, right, and refactor those. And there is a library called ng-react, which provides those bindings that basically wraps your React components in a dumb Angular directive container and handles the plumbing with the digest cycle and all that stuff. So, my thought is that the sooner the better to start refactoring some of those Leaf components. But even more so, I think that a move to Redux in our existing Angular applications would pave the way for us and would solve a lot of the problems that we have. It's a non-trivial exercise, but they do make an ng Redux binding as well. Mm-hmm. And it would allow us to start treating our state in the kiosk application, for example, as a single state store, single state tree that's immutable, that can only be affected by actions being dispatched. And we could get rid of a bunch of this code that's peppered about the kiosk UI that deals with mutating state. So the question of when is as soon as we get enough developers telling George that it needs to happen, and then beating him into submission.
Nice. Well, I have a club.
I mean, there are very valid reasons for not doing it.
Right. Also, do you have any suggested reading to help us get to that aha moment?
There is a space on the rGuest by wiki on Confluence for React onboarding that has some information. And then there's also a space on the JavaScript Guild wiki under the rGuest space on Confluence, where we've started some suggested reading there. And I encourage people to update that page with things that they like. Certainly the React docs from Facebook are excellent. From the Redux homepage, there's a couple of videos that the author links to that are excellent starting points for Redux. But there's a ton of information out there.
Cool. Okay. Thank you, Tim.
You bet. Anybody else? All right. Well, thanks for your time, everybody. I appreciate it.
excellent presentation.
Thank you, Tim.
You bet.
I loved it.
Thank
Thank
you.
you.
Bye.
Goodbye.
You're very welcome.